Hello everyone, I am Shweta from AstronEra and I welcome you all to our new initiative Astro Stream. AstronEra is the world's first astronomy dedicated e-learning platform and we are dedicated to answer all of your questions about astronomy. We have been doing so from our website astronera.org where you can find lots of e-learning content which will answer your basic questions about astronomy such as where do we stand in the universe, how to do astronomy without telescope and whatnot. Today we are doing this live session with Parshati Patel, Dr. Parshati Patel, who is going to talk about careers in the field of astronomy. When I was a little girl, I used to wonder what career options could be there in the field and how I can pursue career in astronomy. And you guys are all really fortunate to receive guidance from Dr. Parshati today about this question, which I am sure you all must have wondered about. You should stay tuned until the end of this video because there is a little surprise announcement for you guys in the end of the video. Before we begin, let me introduce you guys to Dr. Parshati in a little bit quick introduction. So Parshati Patel is actually an astrophysicist and she is based in Canada. With a determination to pursue her career in the field of astronomy, she moved to Canada for her PhD when she was 20 years old. Her PhD was specialized in the field of astronomy, focusing on planetary sciences and exploration of the planets. She has experience of science popularization, communication, and has also co-founded Women of Color of STEM. So let's join with Parshati right now and let's get this session started. Hi Parshati, how are you?
Hi, I'm good. How are you doing?
I'm good too. So we are all excited to hear from you and have your guidance about the careers in astronomy. Off to you.
Awesome. Thank you so much. Hi, everyone. I'm really excited to be here talking about, different kinds of careers you can have in astronomy. What astronomy is it different from the word space? A lot of people use space. Even I use space in a lot of my talks. And I'll also talk a little bit about kind of giving you a sneak preview into kind of what I used to do as an astronomer and what I do right now as my life in a science communication field. So I'm going to share my screen and we're going to get started. So one thing I will note is that, if you guys have any questions, feel free to, put them in the live chat. I know Shweta and her team are taking care of kind of assembling all the questions, and I'll be taking them at the end, so feel free to, put them in there as we go through this presentation. So I'm always fascinated by space, but my personal kind of interest in space lies in star formation and planet formation. And in this picture right here on the first kind of screen I have is actually a really cool Carina Nebula, and it's in the constellation Carina. It's an open cluster. It's a nebula where you have a lot of stars that form. You can see a lot of dots in there. These are like massive stars that are forming, and a lot of the time when people think about space, what they do really like to do is just look up. So you would generally see something like this. These are some of the the lovely views I have had here in Canada. I've been privileged enough to, have dark skies that I can access, take pictures, enjoy the Milky Way galaxy. And so, all these dark patches that you are seeing is actually our own galaxy. And we live in this lovely neighborhood of billions of stars with, many other planets, exoplanets as we call them, and tons of different kinds of stars. And that's kind of where my interest lies. Obviously, over the years, my interest has kind of changed, wanting to know a lot about, what we humans think about space, how we get curious about it, and et cetera, et cetera. But I kind of like to show this picture because this gives you an overview. So every time I go and look at the night sky, I feel like, I'm very much connected to the universe. It's not just about Earth anymore. It's more about Earth and its place in the solar system's place in the galaxy's place in the universe, amongst so many other billions of galaxies. So, the most interesting part is that we are in many ways connected to the universe. The universe is many ways connected to us. And when thousands of years ago, when we did not have internet, we didn't have electricity, we really actually, were sleeping under the stars. We're looking at these stars, kind of, figuring out what are these things, what are these things that regularly appear in the night sky? What are these seasons? And a lot of the sciences that actually started emerging from, looking at the moon, lunar phases, looking at the galaxy, looking at what constellations come around. So in all cultures, including the one in India, tons of cultures in India, but also cultures here in Canada and North America and all around the world, where a lot of them were based on what you see in the night sky. A lot of the storytelling actually came from that aspect as well. So passing on kind of the idea of when for people to start hunting in the season, when does winter come, all of that came from the study of the night sky. And so astronomy in many ways is the oldest discipline you can think of in the in the history of any kind of research science that has been done. And that's just because we were so privileged enough to be able to look at the night sky and just literally try to understand our place in the universe. And if you try to define what astronomy is, it's a science that tries to study the objects and the phenomena around it. And it generally people think about it originating outside the Earth's atmosphere within the purview of astronomy. But I personally like to think of it as space and astronomy are generally interchangeable, because space kind of counts everything, including Earth, even though a lot of people, are studying we shouldn't really think about Earth, but you can think about it as Earth being part of the solar system, that's part of the galaxy, and then that's part of the universe. So, when I'll talk about space and astronomy in this presentation, I'll be kind of interchangeably talking about everything, including everything you can see around. And as you see on here, I have these three kind of subjects noted, and that's one of the things that I get asked most is, do I need to know physics? Do I need to know chemistry? Do I really need to know mathematics? Because a lot of people are afraid of math and physics and chem. I would say that's not the only way you can get in. However, if you want to study what kind of I did, then that's kind of what's required. So I did in my undergrad a bachelor's in physics and a bachelor in astronomy, and most of my courses revolved around physics, chemistry, and math. So if you're really wanting to get into the astrophysics side of it, and I'll talk a little bit about that, you should really, you may not like it, but the more you learn about it, the more you get interested in, the more you're going to like it. So, just hang on to that. And I'm sure I will show you different ways of kind of getting into to the space field that does not require physics, chemistry, math. So there are other ways to do it. All right, so let's kind of talk about these celestial objects and phenomena. What are we talking about? So when we talk about that, obviously, as I said, I'll start with Earth. When we look back at Earth, we use a lot of satellites to look back. We did not have this picture until we had, missions that go to the moon. But also otherwise, we had our first missions were basically launching satellites around Earth, trying to understand Earth's atmosphere, what it's doing, how the atmosphere is being impacted by the rays that are coming from the sun, or particles that are being bombarded by other phenomena outside our solar system. So, we still do that. We have hundreds of satellites that are basically going around Earth providing lots of different things, information about, the cloud cover that you see in the picture here, things like the sea levels, the animals that are moving. So you can think about deforestation. You can think things about, migration of animals, migration of birds. All of those kinds of things are tracked. And obviously we have things like here in Canada, we talk a lot about the Arctic sea ice. We talk about the Antarctic sea ice. All of those things, we do monitor them using satellites, in addition to satellites providing us the GPS and the internet and a lot of those kinds of things. So, when we talk about exploration, or space in general, we definitely cannot ignore Earth, because a lot of our understanding right now and literally everyday base information actually comes from a lot of these things that we deploy into space. And so one of the main aspects of doing that is actually having engineers who can build these satellites, but then also scientists who can actually interpret the data and try to understand what is going on. So you may think about, like satellites or space, you would think about someone who studies planets that will be using the satellites. But you can think about someone who is studying sea ice, or someone who is studying migration of birds, or someone who is studying, climate change. All of those people actually require the use of satellites and the use of space as to try to understand what happens to Earth and its ecosystem. So there are much more wide applications than just it being outward, where we look at moons and other parts of the solar system. And obviously we look at moon with our bare eyes, we look at moon with telescopes, but we also, have lots of satellites on there. So we try to understand our celestial neighbor kind of the most compared to any of the objects in the solar system. So you would need people, to study the moon, such as engineers who would build instruments that would actually go onto these satellites to the moon. But then you also need people like geologists who are going to take the understanding of Earth and kind of apply it to the moon, and actually, frankly, all planets, because when you talk about Moon, Mercury, Mars, Venus, all of these planets actually have a surface, and so we try and understand those using what we understand about geology here on Earth, or using observations that we get from the satellites. One of the most interesting thing about our solar system is it's pretty diverse in many ways. You have, planets that actually have land, and moons that actually have surface, to then having moons that do not have any surface. So you have gas giants and ice giants, Jupiter, Saturn, Uranus, and Neptune. And we try to understand our climate and our atmosphere a lot, whether it's long-term or short-term. And we try and understand the atmospheres on these giant planets as well, and how they evolve over time. And so, it's not just about exploring our own planet, but also it's kind of exploring and looking outside. Now, one of the most kind of heavily studied object in the solar system, I would say, is the moon. Is Mars. And Mars is kind of the place where everyone wants to go and try to see if there's evidence of any kind of, past life on Mars. And the way we do that is sending things like a Curiosity rover, or rovers in general. We have landers, we have, satellites that basically orbit Mars all the time. And again, all of these require engineers, you have scientists, you have astronomers who are helping with, a lot of these planetary scientists that help with like a lot of the transfer orbits that we talk about, kind of the planetary dynamics side of the planetary science, where we talk about how orbits of these objects actually degrade over time, and so how can we keep them in orbit all the time, whether it's around the moon, Mars, or any kind of object. So there's a lot of sciences that is involved in studying these things. But you can also think about, we're in an era where we're going to go and, hopefully in a few decades, maybe have a moon base. In a few decades, have a Mars base. And when you start thinking about those things, you have to start thinking about a few things. You have to think about, okay, once someone goes and makes a Mars or a moon base, who is that, who is that place dedicated? So for example, here on Earth, I can buy a house. That land is mine. What about on the moon? If I go and live on Moon or Mars, is it mine? Is it a government? What government is it? There's lots of these policies and laws that actually come into effect. One of the other things which has been, talked about lately is what about private industries? A lot of private industries are making these, landers that they're making rovers. Eventually, they'll be sending humans to space and to, places like Moon and Mars. What are the rules around that? Who is going to follow what rules, And so a lot of this comes in policy and law. And so that's kind of one of the newest fields that people are really actually using to understand the dynamics of the space, the diversity of things that's going to come in next few years. But then at the same time, you're also thinking about how we're going to progress with the kind of progress that we're making and at the scale we're making. So that's another aspect that, is very interesting, and that does not require generally any physics, math, chemistry courses, but definitely requires a background in policy and law. All right, so let's keep moving. We talk a little bit about, our solar system. Obviously, we have our sun, so we're trying to even, as an astronomer, trying to understand what our sun and other stars are doing. We use things like telescopes and observatories, and around the world we have tons of observatories, whether it's on the surface or above the surface. And all of these observatories need technicians. They need people who build instruments, people who build the robotics for those, but at the same time, scientists who can interpret a lot of data. So you will hear me saying the word data a lot in the presentation, and that's because the amount of information we're gathering right now is way more than what we can process. So really, the new techniques like artificial intelligence and machine learning are actually playing a key role now and in future to actually understand and evaluate a lot of the data that we have currently coming in. Just because we don't have as many astronomers, the amount of data that we are getting on every minute basis, actually. And so we use computers to actually automate that process and have them look for things that you would as a human look for. So studying, our solar system also requires studying a lot of data, but the same is also for looking for formation of planets and stars. And this, is my particular favorite topic, and that's because this is what I used to study for my PhD. So on here, you are seeing this lovely star-forming region where each of these dots are actually massive stars that are forming. And we are lucky to have, telescopes like Hubble that are actually able to catch these stars when they're forming and show us the whole wide range of the ways these stars form. And again, you are now starting to look into the deep end of astronomy, where you cannot actually physically go. For places like Moon and Mars, in maybe a decade or two or a few decades, we might have settlements that can actually do the science there in person. For stars and galaxies, that's definitely not going to be possible, at least in our lifetime, unless we have a really, really crazy exponential growth in the kind of technology that exists. So, you can think about having to sit here and do a lot of science without actually being able to touch or feel or sense the object that you're actually studying. So a lot of the data and the kind of theories actually come from trying to understand what we see, how we see it over the time, and trying to come up with theories based on that. So now I'll show you an example of my thesis so that you guys can see how we actually make that happen. As we go further out, you're now looking at galaxies. So, when you're looking at a galaxy like this, you're thinking, okay, what are these? How are these made of? Obviously, we know that galaxies are made of billions and billions of stars, and they come in different shapes and sizes based on our observations. But then we kind of want to go further. We kind of want to think about how stars play a role in galaxies, and then how galaxies plays a role in the universe, and just in general how the universe came into being. So here's another photo, which is one of the favorite photos of all time of mine, is because this one is a picture of a very small area of the night sky, actually in the Ursa Major constellation. And every dot you're seeing in here, except the few bright ones, which are actually stars in our own galaxy, each of the other ones are actually, each point is a galaxy. So you can imagine how much of the picture that you're seeing is actually a galaxy like this. And so each of these galaxies have billions of stars, and then you can imagine a lot of these stars would have planets around them. So this brings into the context of thinking about it from a philosophical side of what it means to be alive in the universe, what it means to have planets, life, but then also on a flip side, thinking about looking for life. So, you know, I mentioned that we are going to Mars, and we have been going to Mars for a very, very particular reason. We think Mars was very habitable at one point. It had oceans, you know, of liquid, and we are thinking that is probably where, you know, it would have had life. The really neat philosophical but also scientific question is, when you're thinking about life in universe, are you talking about what we are seeing ourselves as? Are we talking about everything we see here on Earth? Or are we talking about something that's completely different, that we may not have encountered before here on Earth, we may not know what it is like, but then on the flip side, what are we really looking for? So that's actually one of the other really upcoming neat, you know, kind of field that people actually study, and you know, I know personally a few astrobiologists. It's pretty cool that they use you know, what we know about life here on Earth. They try to understand the life here on Earth, where it originated from, etc., and try and find ways to apply it to the kinds of you know, exoplanets we're seeing, or bodies in our solar system too. I mean, you can think about Titan, you can think about Enceladus, all of these objects where you would think that there is a possibility of all of these materials that exist here on Earth, or at least what we know is needed for life. So, you know, this kind of gives you like an overview of what a really large field of spaces condensed in a very, very small 3 slides actually is. But let me actually point out a few of the kind of areas of research that I mentioned throughout these, and then let me point out a few more that I didn't have a chance to talk about. So starting from robotics to instrumentation, this is when, you know, we're sending a lot of these instruments, whether it's telescopes, you have satellites, you have robots that are like rovers, landers, you know, satellites for other bodies in the solar system. All of these require robotics and instrumentation. So if they're really into hands-on making things, this is probably what you would like, is actually getting to build things. But if you're someone who loves, you know, the aspect of actually operating things, mission operations is one of the other field of space, which is very upcoming and pretty interdisciplinary, because you're working with a team of scientists, you're working with engineers, you're operating these, you know, amazing pieces of creation that humans have built to explore the space. And then obviously when you send those things, you're doing some kind of research. You have planetary science. This includes studying of planets, includes studying how planets form, the dynamics that goes on in the formation of stars, but also at the same time trying to understand, you know, what is happening with these objects over a long period of time. Stellar astronomy, which is what, you know, my field is, stellar astrophysics is what we call. This is study of stars. It involves everything from giving birth to, you know, having it evolve over time, having it die, what happens to the stars during the meantime, all of those kinds of aspects. And then we kind of move on a larger scale. We talk about galactic astronomy. So this is kind of studying the galaxies, formation, their mergers, how they, you know, move around each other, how they form, all of those kinds of things. And then kind of the most biggest picture you can think about is cosmology. This is very much of the understanding of universe, how they form, how our universe formed. And then you have questions like how did the universe came into being, but then are there multi-universe, things like that. And then there's some other not very specific areas of research that people think about, so I've kind of highlighted them. Astrochemistry is one of them. So this is an area where you're, you know, where if you are really great at physics, math, and chemistry, and you really like chemistry, is where you can go into. It's kind of studying the chemistry or the molecules between stars in the galaxies around in the solar system, things like that. You have astroparticle physics. You have a lot of these amazing high energetic particles that are being bombarded. So trying to understand what those particles are, where they're coming from, what impact they have, things like that. I already mentioned about astrobiology. It's a very, very neat, cool field. And then we have atmospheric physics. So a lot of the time when people think about atmospheric physics, they think about it being just studying the atmosphere of Earth. So yes, you start with the study of atmosphere of Earth, but what you're really doing is taking that and applying to other places in the solar system, and now also around planets, around other stars, so exoplanets. And you have brown dwarfs and a lot of these different kinds of objects that you can actually apply atmospheric physics to. So that's actually a very integral part of space and / astronomy. The last of the three ones are something that people generally don't think about. Space education is something that I'm doing, like what I'm doing right now, which Shweta does with AstronEra. That's basically taking the knowledge that we have, passing it on to people who may or may not be interested, or if they're interested, then they may not know about. So finding ways to actually educate people about space. Space policy and law, I talked about this. This is a very, very new upcoming field where, you have people who are looking into these complex, issues and complex, situations where you would have any kind of law and policy involved. So this could be, even just simple, say, sending satellites to space around Earth, to anything from going to actually put a lander that may not be as clean on a planet or a moon that might actually have life. So how are you, maybe are you contaminating that place? All those things come in law and policy aspect. And then last but not least, which is something that if you think about of exploring space in many ways, is what you would think about as health and medicine. A lot of people don't think about that. When we send astronauts, we require people who monitor their health constantly, people who are nutritionists or are into food science and think about what these astronauts are going to eat for whatever the length of their mission is. But also at the same time, when we're thinking about sending humans on long-term missions to Mars and other places, we have to think about what the consequences of microgravity, as well as radiation and the harsh environment of space is on humans. When we're talking about sending them for 3 years, we don't generally think about, the amount of radiation they're going to be exposed to might eventually cause them cancer. Is it safe to send them? Is it something that should be done? We have to think about those things. And space is super interdisciplinary, so you would have a lot of people working from different areas talking about this. For example, let's take an example of going to Mars. You have doctors who are working with the astronauts. You have food scientists or nutritionists working with the astronauts. But then you also have people in law and policy who are going to be, what are going to be the implications if this person gets sick because of the exposure to the radiation. You also need someone who is specializing in radiation or someone who understands how radiation affects your body. So these would be people who study the effects of radiation, could be in health sciences, could be in physics or interdisciplinary team as well. So there are lots of people who take into account, then, that's not even counting the engineers who make the place where these astronauts are going to live, the kind of instruments that they're going to have to work with, so you have people who do instrumentation, mission operations, and then obviously scientists who, would want them to go there and do some science. So you have all of these people kind of working together to make a mission. So it's a very, very interdisciplinary research area. So I kind of highlighted a few careers that you could have. So I'm kind of going to go through them in a little bit more detail. So we have, researchers at a government agency or university. That's a very common, where you basically dedicated all or some of your time to research. But then you also have people who are, engineers at these government agencies or industries or even universities, where their basic idea is to understand the kind of engineering needs for a mission or whatever scientists need to do the science that they need to do. You have astronomers who are technicians at an observatory. That's a very, very cool job. However, over the years, it has kind of gone down, and that's one of the reasons is because obviously we have now computers to automate a lot of things, and so we generally only require a couple people at an observatory to be operating that. So it still exists. It's a very, very small number of people who actually do that job. You have professors and lecturers. Obviously, you need people to educate the next generation about it. So you have lots of positions where people actually get to talk about space. You have the rest of the ones may not be as apparent. Well, astronaut is very apparent. A lot of people want to be an astronaut, and that's basically a job where you learn a lot about how to operate different kinds of instruments and whatever vehicle you're going to be on, as well as where you're going to be leaving, for example, International Space Station, and do the science when you go up there. But a lot of the rest are very, very obscure that people don't think about. One of them is a data analyst and data scientist. I talked about how there's so much data to be piled through that we need people who are specialized in data analysis and data science. And so, people take that sometimes, if you don't find a job in the area or in the field that you like, people move into industry. So it's a very, very common thing. One of the things we astronomers, or I guess many scientists, all scientists actually do really well is management, because we are managing so many projects at the same time. Eventually people, if they don't want to stay in the astronomy field, or even if they want to stay in the astronomy field, they actually take their project management experience and move into industry, or sometimes even government agencies to be doing basically project management of space-related projects. So that's a very, very interesting thing. Then you have science consultant and scientific education and publishing. So this is very much about, you can have movies and TV shows that need people, or even people who write books, need science consultants to actually check and make sure the science is correct, or at least it makes sense. And, a lot of people also publish a lot of books as well. So that's pretty interesting. You have climate scientists or meteorology. So you take whatever you have learned from studying the atmospheric physics here on Earth, you can apply it, here on Earth, you can apply it to other places like I mentioned before. One of the other ones is software development. A lot of the work that we do in astronomy requires a lot of development, or at least a lot of coding experience. And so, that kind of comes natural. I have many friends who are into software development, and also many friends who are into data science now, just from the experience they have had in their master's and PhD. Couple of other ones, science policy and law, which I already talked about, and we also have an educator or teacher, so someone like me who kind of spends most of their time educating. So this kind of gives you an overview of, the different kinds of jobs. Obviously, there are much more than what I've described. You can have an engineer, you can have tons of different kinds of engineers. You can have a researcher, tons of different kinds of researchers. But just to give you like a very, very broad overview of the different kinds of topics that we can actually study or do. So now, in the next, hopefully 10-ish minutes, I'm going to try and, go through kind of my life as what it looked like to be an astronomer, and then now what it looks like to be a science communicator. So let's peek into what it is to be one of the two. So let's talk about the cycle of research. So when I started my PhD, I had to look for a mystery to kind of solve. And so, your master's and your PhD thesis has to be something that is very new, very fresh, something no one has done before. And so, we had to first go look for something that would interest me, something that has not been done before, something that would allow me a long amount of time to kind of, think about it, look for data, look for other people's work, obtain data, process, and over time develop a theory and test it. So, as I said, I'm very fascinated with star formation and planet formation. And so I chose the kinds of stars to study. Those were the very, very young stars. So these are stars that will eventually become, stars that are much more massive than our sun. So in this picture here, what you're seeing is a star-forming region. And this is where all the stars form. You have the right amount of material dust, gas, and kind of the shock waves that allows the star formation to actually happen. But then, depending on the amount of mass and material available, you can get a wide variety of stars. So the top picture here basically shows you the different varieties that we have for the kinds of stars that you get. Our sun is a G-type star, which is this big, and this is to the scale. So G-type star was this big. The biggest star, O-type star, would be this big. So you can see two distinct things. They're changing in size, but they're also changing in color. And that's because the more massive you get, the higher the temperature on the surface, so the more white you will see. Sometimes if you have looked at the stars in the night sky, you would see that some are really blue, but some could be reddish or orangish in color, especially if you have used telescopes before. And that's because of the size and the temperature you can see on the surface. So I actually picked to study the B-type stars right here, and that's because they're not the most massive, but also not the least massive, and kind of on that spectrum where they edge right when the most massive stars are formed, which actually form behind a thick cloud of dust and very, very fast. So what I was studying is actually something that looks like this. So if you had a B-type star that is forming, you have all this material that is being dumped into the center. If I were to cut it from the middle, this is what it would look like. You have a star in the middle. You have some area between the star and the disk that nothing exists, or at least it looks like nothing exists. There is gas that exists that we interpret as nothing in this picture. But then beyond that, you see a lot of dust that is now forming these clumps. Eventually will form rocks and boulders, and then later planets. And so I was really interested in studying this area because people study this area a lot because eventually planets form. They find it super interesting. Even I find it super interesting, but I wanted to do something that no one had done before. So I was looking to study this area where only gases exist. And so the way we did it was we actually used our tools. So we have lots of different tools. We're lucky to have tons of different kinds of observatories. We have the Canada, France, Hawaii telescope, which I was one of the lucky people to be able to actually apply for and use the telescope for my research. But then we have other telescopes, like we have the Hubble telescope, we have the Sophia Observatory, as well as the Chandra X-ray Observatory. Depending on what you're using for, you would use one of these tools to actually look at your stars. And the interesting thing is that because we're so far, all we get from them is light. So this is one of my actual data that I got from the Canada, France, Hawaii telescope. And it just looks like long lines of these, dark and light patches. What it really is if I were to stretch it on spectrum, which is basically a rainbow image, if I were to look in the visible range, I would get this really dark or light patches depending on what I'm looking for. So for example, you have the white patch here. All of those are bright lights. If it's emission, you have darker patch that are absorption. And each of these are like fingerprints. Each of these tell a different story. They are dedicated to each different element, just like how each human has a thumbprint that's very much unique to them. We have elements and molecules that have a very unique signature. And so what it really looks like is, we'll not go into very much detail of this particular image, but what this is on the y-axis right here, we have the amount of light that you are getting. And then this is basically that previous image of red to blue. So if you go right here, we have, red to blue, basically stretched out. And so you can see a lot of these spikes in this, right? So each of these spikes are basically indication of a particular element. So over here is hydrogen. This is all iron, all you're seeing here. This is oxygen. All of these are basically different spikes that tell us where in that system or the star we're seeing all of these elements, and that actually allows us to understand what the structure of the disk and the star actually looks like. But obviously with this data, I cannot just say, okay, we see this, now what does it tell us? So in order to kind of understand and imagine what it would be like with the kind of science we know, we actually use computational models. So this is actually my supervisor's model, Dr. Aaron Sugget's. I credit to him for allowing us to use this image. This is an actual computer model that I worked with that has a star in the middle. This is the massive stars that I worked with. And then we were able to recreate this disk for the exact same picture that I showed you before of that spiky things that we were seeing. What we really do is we create a disk and a star in a computer and then try and compare if we see the exact same thing in the spectrum of the star that we are seeing, or we use the giant telescopes to see through. So a lot of the work is basically comparison. You use your understanding of physics to create these stars and disks, and then you look at the observations and you try to figure out, okay, it looks like I'm missing something in my model because this is showing a spike here, but I don't have it here. So what am I missing? And then you keep going back and forth with a lot of data to understand what is happening around these stars. So that's a very, very, short kind of view of my research, but really what we, spend most of the time is actually communicating our work, because, we're doing a very, very small amount of, we're doing research in a very, very small amount of area. And so one of the most important things we do is we actually attend a lot of conferences. So you're seeing here as one of my first international conferences that I went to. I'm talking about the disks and how I'm studying them and what I'm seeing in those disks, and talking to other astronomers what they think about it. But then a lot of the things, communicating also involves writing papers, reviewing, and looking at other people's work, giving seminars. So, talking to your colleagues in your department, your peers, trying to understand, and get their feedback on what you're doing and whether they have a different technique that they use, maybe that I don't know of. And then obviously we spend a lot of time on actually getting money to do this science, so grant proposals and observing proposals, because there are only so many observatories on Earth, and everyone wants time on it. So they cannot just give everyone time. You actually have to compete on almost, there are generally 2 or 3 cycles a year that you compete with other astronomers for even 1 or 2 hours worth of the telescope time. I was lucky enough to be able to get 4 hours on the Canada-France-Hawaii telescope on my first ever proposal that I wrote. And but people are not that lucky. It's a very competitive process, and you actually compete for this kind of time on telescopes with a lot of other people around the world. So what would my day look like as an astronomer? I'd be coding models, I'd be extracting, cleaning data, I would be writing papers, I would be analyzing data, I would be attending conferences, reading papers, observing proposals, a lot of different things. So, there's a whole multiple aspect of astronomy that I do on a daily basis. But eventually I realized that I really love talking about space and talking about just, how amazing space is. So then I moved into my life as a science communicator, where really what I do is talk about science all the time. So, my current job, and I'm also very, very lucky to have a job where I get to do this on a daily basis. So here's an example. Here's a picture of me talking to a bunch of students and parents, meteorites. And I get to do this often, where we go into schools and we talk about space. A lot of the schools, at least here in Canada, have space as part of their curriculum, so they do have to study it in grade 6, at least in Ontario, grade 6, grade 9, as well as grade 12. So we make sure to bring in the expertise that we have so that students can actually ask questions. I also do, talking a lot about space in media. And that's because, there's always times, like, for example, tonight is a lunar eclipse in India, or at least a part of that world. And, if it was happening here, I would be talking to media of how cool it is, what are things you'll be seeing, what the times, things like that, just so that people get excited and aware of the things that are happening around them. I've also in the past, consulted with, here is Dr. Dave Williams. He's a retired Canadian astronaut. He wrote a children's book, and he needed someone who was an astronomer and or planetary scientist to talk, to just look through his book and make sure that everything that was in there that was accurate, and so I kind of landed my expertise for his book. So that's some of the cool things that I get to do as part of my job. But it might look very public facing position, but there's a lot of things that you do that people don't actually get to see. So Life as a Science or Space Science Communicator, it involves not only leading workshops, but also, developing programs and activities, organizing events, conducting research and analysis on the kinds of programs you're running, whether it has any impact or not. We do a lot of social media and promotions, so you have this marketing aspect that comes in. But then you also do a lot of staff and volunteer management. So again, that project management thing that I said that I learned in astronomy is kind of applicable here. So you can see there's a stark contrast between my day as an astronomer, which I used to have when I was doing my PhD, to now in a life of a science communicator that I live. I have two different, very, very different kinds of days. I don't do coding anymore. However, sometimes, just because the way I'm bred for master's and my PhD doing a lot of coding, sometimes I think about automating some of these research that I do with the science communication into literally coding, because I'm like, I can just code that instead of having to do it over and over again, right? So a lot of the skills acquired over the time can actually be passed on into whatever you end up doing. And that's probably one of the most needed things that I've learned about space, is it's super interdisciplinary. You can take your skills from one aspect, easily learn and apply to other fields. And so I'm hoping that this gives you a real clear overview of the different kinds of careers you can have, but then at the same time kind of a little bit about the tools and kind of technology that we astronomers use to study space in general. So I'll just leave it at that, and I'll take questions. If you guys have any, please make sure to put it in the chat, and Shweta and her team will just go ahead and ask me.
Yes, thank you, Parshati. That was really insightful. We have so many questions. So first of all, I just want to say thanks for everyone who's attending, and also sorry if I could not cover all the questions. But before I ask any question from our viewers, I have one question for you, which is, I'd like to know what inspired you to pursue a career in astronomy. Could you please answer that?
Yeah, so I say this all the time. I'm from very young age, I was super curious about just like everything. It didn't have to be science. It was just like history, mathematics, give me any book and I'll be like, oh my God, I want to learn about it. And on one of the trips, my family, we used to take vacation trips all the time when I was very young. And one of those trips actually visited Mumbai, and I got to see a planetarium for the first time. I got to see the Milky Way and the stars. I didn't really know about planets and any of that stuff until I went to that planetarium. And so when I did, I was just like more curious about it. It wasn't something that I knew that this is what I wanted to do at that time, but I just grew curious, and the more books I got, the more excited I got about it. And so when I kept asking for more books, everyone who had to gift me would basically do that. and what ended up happening was my aunt, who lived in Canada here, ended up gifting me a telescope, and that was something that I found was the coolest thing, that I had my own telescope. I could set up on my terrace and look at these amazing objects. I thought it would be amazing to be able to study these and actually have my own observatory. I did not know what it took to have your big giant observatory. I just thought that I was so young. I did not know much. That it would be cool to have your own observatory to study these things and understand how they form and what they do. But that's kind of when I decided that I wanted to study and pursue astronomy. Obviously, since then, I have learned a lot how things, change, what are different kinds of careers you can have, and kind of navigating through that. So, yeah, so first, that inspiration, I wouldn't say, but like the inkling to know more came from the planetarium visit, but I think the telescope kind of sealed the deal.
Yeah, well, it actually makes me relate to my story a lot. I think the journey is pretty similar. When I was studying in school, I had a little bit about solar system in my geography book, which is somehow an irony. And then, I struggled a lot to understand if there was a career in astronomy and how to do it. And the basic path that I found out was I had to do science for my 11th and 12th grade, and then do BSc physics, then masters in astrophysics if you were to study in India. So that was the only path. And then I figured out that nowadays there is some online courses as well. So I found out University of Central Lancashire, from where I'm pursuing my bachelor's now. But pretty much I have learned that after you complete your master's in any subject in astronomy, you have to take your first PhD, then second PhD, then one more master's, and it continues with the research. So that's like the base career path in astronomy, I would say. But I think you covered it pretty well when you said that astronomy has so many topics under it. So I think it's important for everyone to understand that astronomy is not just one subject that you can study.
Yeah.
I mean, you have to understand if you are interested into planetary sciences or stellar astrophysics or cosmology or radio astronomy, and basically you can put astronomy in front of any science, and that becomes a part of study which you can choose as your specialization. So let's go on to the question that people have asked. Okay, so Ayush Deshpande has asked, can we start colonizing planets other than Mars? And if yes, then when?
That's a very good question. I think I know that there have been companies and industries that are working towards wanting to send humans to Moon, Mars, and other places. I think colonizing isn't really the word I would use. I think I would use human settlements. Also, like that has its own history. But I think we're not at that stage where we really understand the implications of what happens to humans on a very, very extended period of time living on other places. Even just, we have had astronauts live on the International Space Station for a year or longer, and we see changes in their body that we need to understand and find a way to ensure that this doesn't impede their daily activities or even their life on a long-term basis. And so we are trying to currently understand how very, very long term, just living on their planets, like forget about even just visiting them. So the idea for the first mission to Mars is that we send humans for 3 years, we send them there, they do some science, they come back. And even then, that's 3 years. We don't know the kind of effects it's going to have on the body. And so I think we're decades away from having human settlements. I mean, realistically, unless we have a very, very great kind of technology and the explosion of research that would happen, I think I would say kind of later in maybe 2060s, 70s is what I would think that we would possibly have. But that's very much dependent on what kind of technologies will come on between now and what kind of research will happen between now and that time frame. I think we're very, very far away from having human settlements on even Moon or Mars. Those are the two most studied objects in our solar system, the ones that are closest to us, the ones that we find very interesting, and yet there's so much we don't know about them. So, we're far from it, but, hopefully we will have a lot of people who would want to do research in this kind of field so we can actually move faster towards that that particular plan.
Yeah. Okay, so I can see that many of our viewers are actually asking about the study avenues, and we have wide range of them. So Sanika J is actually preparing for her JEE, and she wants to know how she can enter into the astronomical field. Then there is Krish Pandey, who's really young, still in his school. There is Pooja, who's in 12th grade now. So many of them just wants to know what they should do after their schools and after preparing for JEE. So if you can just throw some light on it.
Yeah, so let me start by talking kind of about what I did, and that will give you kind of one perspective. And obviously, there are different perspectives and different, paths you can take. So I knew, just like Shweta mentioned, I knew by entering high school that I needed to have math, physics, chemistry, or sciences. I had to take grade 11, 12 science, and so that's what I did because I really knew that I wanted to study planets and stars, and that's what I would need. I ended up I enrolled into BSc Physics. I actually finished 2 years of BSc Physics in India. And then just actually when I was entering my bachelor's, I got to talk to a lot of scientists in India, and I asked them, what path should I be taking? A lot of them actually suggested me to go abroad, and I say I'm very privileged in many ways because my parents were able to send me, to Canada to study, to do my bachelor's. So I actually restarted my bachelor's here, and it took me 4 years to finish. And I studied bachelor's in physics and astronomy. And the reason I had to redo most of my courses here was because when you transfer, you do not really get all the courses that you did in India. Also, there is a whole different range of courses that you have to take here compared to India. But the reason why I moved was because I was suggested that I should do that by a lot of people who were in India at that time. And however, right now there are much more opportunities that are available. There are so many institutes and research labs available. There are many universities that actually offer bachelor's, BTech, MTech together that actually concentrate, even though it's kind of engineering, you can pick astrophysics as your field. There are places like, Indian Institute of Astrophysics, Indian Institute of Sciences, you have IUCA. There are lots of places where you can actually do your master's and your PhD in astrophysics. I know there is still very few places in India that actually give you bachelor's in astronomy. And one of my key reasons to kind of move to Canada or move outside India was the fact that I wanted to start with the basic in astronomy. And the reason for that was I wanted to study it, but I was still not sure if I would be able to do it. So I didn't want to have to, do physics and then just, then find a master's or a PhD program, get into it and be like, no, this is not something that I was anticipating, or this is not something that makes me happy anymore. So I wanted to do a bachelor's in astronomy. So when I moved to University of Toronto, we're lucky enough to actually be able to do bachelor's in physics and a bachelor in astronomy. So that's 2 different degrees combined into one, but you are able to take courses from different areas based on which degree you're doing. And so I kept physics as kind of my backup because I knew I liked it, and I knew that would, at some point I would lose interest in astronomy. I'll still have physics because I know I like it and I know what it looks like. So there are a few ways you can do. What you can do if you're in school right now, make sure to, read books. You now have access to internet. I come from an era where I didn't really have a lot of internet. I did have some, but not a lot, to be able to do all the research online. So, read books, read the scientific blogs that are meant for youth. Try and get organizations that can help you actually to understand more about astronomy. And for undergrad, if it's possible, depending on, your scores, different kinds of national tests or even local ones, you can find ways. There are very, very small amount of bachelor in astronomy or bachelor in physics with a concentration in astronomy is available. So I would say, start with that, even if you're not able to get into, because there are very less number of seats for all over students in India. If you're not able to get into that, get into physics. If this is at least if you want to study the astrophysics aspect of it, it's good to kind of get into physics side of things. Physics and math is what I took in my bachelor's. If we're looking to get into engineering, so aerospace engineering or any of the engineering aspects that I mentioned, robotics, instrumentation, go into BTech, take engineering, take ECE. A lot of people do that, electrical and computer engineering, to be able to get that engineering experience before in your master's you actually move into the area that you really want. Unfortunately, in India, there's not a lot of opportunities for bachelor's. There's tons of opportunities for master's and PhD. I'm hoping that as time passes, you will have more opportunities at bachelor's as well. But I think that would be my kind of advice on how to navigate.
Yeah, okay. So we have a very specific question from Aditya R. He is asking, I have done my bachelor's in mechanical engineering and a few courses in astronomy. Which stream would you suggest be ideal for masters so that I could integrate both my technical and theoretical knowledge?
Yeah, so that's a really good question. I actually personally know someone who just finished a mechanical engineering degree a couple of years ago, and that person is looking into getting into electrical and computer engineering because he's very much into robotics and building rockets and things like that. So if that is something that interests you, you could go into to ECE or even aerospace engineering departments, depending on where you are, with a concentration on them actually doing projects in this field, because you can have a lot of electric and computer engineering projects that does not involve anything with space, but trying to find those kinds of projects is very important because you want to make sure that you have your interests blended in it. Another alternative is a lot of the people in astronomy do take students with engineering background is when they're building instrumentations for their lab, because a lot of the things that we do, like practical astronomy, believe it or not, it still happens. That is done using people with the astronomy background, but also with an engineering instrumentation background. So if that is something that interests you, look for people who have that kind of research projects and ask them to basically take you for your master's. So, just having to look for those people is kind of the hardest part, but go look at the website. At least, I know that here in North America, a lot of the people put on their website what their research projects are, what they plan to do as well. So something that gives you an insight of what you could be doing, but also just sending an email. Right now, all the universities, even in India, all the professors, they're all working online. You can go and shoot them an email and be like, hey, I would like to learn more about your research. I want to bring in my technical experience from engineering and blend in my astronomy interest as well. Do you have any projects related to that? It will require a little bit of research into who you should contact, but that's really the key, is to look for people that do research in the area that interests you.
Okay, then we have an interesting question. Dhananjay Kapse is asking, can science communication career be pursued as full-time career? And if yes, what are the possible ways?
Yeah, so I am currently pursuing, I have a job that's full-time, related around, like literally what I showed you guys is kind of what I do on an everyday basis. That's my job. But so in India as well, there are tons of science communicators. If you're on Twitter, go follow IndSciComm. They highlight a lot of people who do research as well as science communication, but also just science communication. I know that there's a lot of research that also happens in the field of science communication. So you can think about, when you're talking to, let's say, a group of students, or you're talking to a group of members of public, what are the things that they're asking? How are they asking? Is this, what you are doing? And I know that the science